One of the major segments that we're going to look at here for triangles is the angle bisectors. So to look at the angle bisectors, we're going to look at first just drawing a triangle. So we're going to use our polygon here. We're going to draw a generic triangle. It doesn't matter what shape that triangle is. We're going to draw on that triangle there, and we're going to look at the angle bisectors. What an angle bisector does is it cuts each angle of a triangle in half. So here's our angle bisector. We're going to start off by choosing our 3 points. We're going to go C, A, and B. That will lock that angle bisector in place. Notice that the angle bisector is drawn at the vertex of the angle. The vertex of the angle is always represented by the middle point when we list out an angle with the 3 points. So we did CAB, putting the vertex at angle A. So now we're going to put an angle bisector at angle B. So that B needs to be the center point. So we're going to go A, B, and C, locking it in at angle B. And then again, we'll go and we'll put one at angle C. We'll start at A, C, and then B. That locks in our last and third angle bisector for our triangle. Taking a look at the 3 angle bisectors of the triangle, we can see that they all intersect at the same point. So we're going to use our intersection tool to identify where that point is located. So we got point D here. That is the point where all 3 angle bisectors intersect. That point is what we call the incenter of the circle. So to establish what the incenter really means of the angle bisectors, what we're going to do is we first actually need to find a perpendicular line off of one side that crosses at point D. That is an important feature for us because we're going to be drawing a circle on the interior of the triangle. So I'm going to draw that line like I did. We're going to look at the intersection of that perpendicular line and the edge of the triangle that we intersected it with. And then we're going to get rid of that line. We do not need that line anymore, so I'm going to hide that line from our view. So we do not need to worry about that anymore. What that was for is to help us draw a circle so that the circle goes with a center at the incenter, and it has a point on the edge of the circle. When we talk about the distance that a point is away from the line, we want the perpendicular distance from that point to the line, which is why we had to use that perpendicular line to find that point E there. Now that that point is established, what I can do with this is we can take a look at the incenter. As we move it around, we'll notice that some of these points of concurrency, like the incenter, when we manipulate it to an obtuse triangle, sometimes that point ends up on the outside. For the incenters, you notice that no matter if it's a obtuse triangle or a right triangle, that was almost a right triangle. There we go. There's a right triangle or an acute triangle. That incenter is always on the interior of our triangle. So no matter what we do to that triangle, we always have an incenter in the interior of the triangle. Now let's take a look at a real life example of where the incenter might be used. So what I'm going to do is I'm going to download a file here or insert a file in the background. What I chose to use was something off of a map. We're looking at the cities of Indianapolis, Cincinnati, and Louisville. So we're going to increase the size here. We'll drop this down. I think it's a little too big. We'll shrink it down a little bit. We'll get a little level there. There we go. So let's say you are building a business. Let's say you work for like Amazon, and you're building an Amazon distribution center. That distribution center is going to serve the communities of Indianapolis, Cincinnati, and Louisville. So if that's the case, and you want to find a location that is the same distance away from all three highways. So if we look at Indianapolis, Indianapolis to Cincinnati is connected by Interstate 74. Indianapolis to Louisville is connected by Interstate 65, and Louisville to Cincinnati is connected by Interstate 71. If we want to find a location of a distribution center so that it is the same distance away from all three of these cities, what we would do is we would locate a point at the center of each of the cities, create a triangle, and then look at the incenter of that triangle. So you can see here we have looks like probably a state park in the middle, or a national park in the middle of all three of these cities. But that park is about the location where Amazon might want their distribution center. That park, or that just north of that park, would probably be the best spot to be, where you are about the same distance away from I-74, I-65, and I-71, so that you can easily have transportation to all three of those cities. That would be a good use of an in-center. Again, in the real world, it's not going to be perfect. You can tell that these highways are not perfectly drawn so that they are triangles, but it is triangular in a scenario, or in a formation, and it does show you a good representation of what an in-center could be.